Welcome to the Rich Report, a podcast with news and information on high-performance computing. Today, my guests are from the InfiniBand Trade Association. We have Bill Lee. He's the co-chair of the Marketing Work Group for IBTA. And we have Rupert Dance. He has a couple titles, but he is the chair of the Compliance and Interoperability Work Group. And he's also editor of a new specification that just came out for IBTA. So we'll be talking about that. But gentlemen, welcome to the show today.
Great. Thanks, Rich.
Thank you, Rich.
Thanks, Bill and Lee. So today we've got some slides about the new spec, and I thought we'd just go into that. I brought those on my up on my screen here, Bill. So why don't we start with you?
All right. Great. Thanks, Rich. We'll start on slide 2. Just a brief introduction to the InfiniBand Trade Association for your audience who's unfamiliar with us. We're an organization that's dedicated to the developing, maintaining, and furthering of the InfiniBand specification. What this means is that our architects work on the definition of the RDMA interface up to the application, all the way down to the wire. InfiniBand currently is specified for up to 100 gigabits per second or 300 gigabits per second per port. We also specify the RDMA protocols to run over Ethernet, and we call that Rocky. In addition to specifying what InfiniBand is and RDMA over Ethernet, we also test compliance and interoperability to ensure that people who are deploying our products are capable of or have a high sense of ease deploying multi-vendor equipment into their data centers. And we also market and promote InfiniBand and Rocky, talking about what the organization does and promote what our members do. On slide 3, you can see the history of InfiniBand. The first specification was released in 2000. And since then, the majority of the changes have been improvements to speed. The fundamental architecture of the specification remains sound even to today. You'll also see highlights of where the new speeds showed up on the top 500. People who build supercomputers want the latest and greatest. And shortly after the InfiniBand Trade Association releases a spec and its members release products, these products end up on the top 500. On slide 4, you see a roadmap. We aren't content with just being able to deliver 100 gigabits per second today. We have in our sites now 200 gigabits per second, which we call HDR. Our architects are looking at the technology today and expect to have a spec by the end of 2017. And then move on to the next speed.
So today we're announcing the 1.3 release of the Volume 1 spec. And the significance of this new spec is that we're preparing for increasing the scalability of the InfiniBand fabric as we move into the exascale time frame. And some of the things we're trying to do is we provide a deeper visibility into the switch hierarchy. Obviously, we're connecting a lot more nodes in a fabric, going from thousands of nodes to 10,000s of nodes. And as a consequence, we needed to improve our diagnostic mechanism and also the response time for managing our overall network. So this spec is basically a collaborative effort between a number of different work groups in the IBTA. The link working group is responsible for the physical side of the Volume 1 spec. Obviously, the management working group is responsible for all the management portions, and then we have a software working group that deals with the software side. In addition to that, the IBTA has a compliance and interoperability working group, and that group is responsible for making sure that the hardware that is produced using these specifications actually is compliant with and meets all the specs. The importance of the CIWG is that there's actually 2 different specifications. There's a Volume 1 spec, which is more of the management side, the protocol side, and then we have a Volume 2 spec, which is the physical layer side. And what we do in the CIWG has Plug Fests twice a year, and what we do in those events is we take and collect all of the equipment being produced by our IBTA members, and we test them for compliance with the spec. That hardens the spec in two ways. One, it makes sure that the devices are compliant, and good compliance leads to very good interoperability, so that's one important aspect. But the other part is that it not only validates the devices and the equipment, but it also ensures that our spec is correct. Sometimes we find that we need to adjust our specs one way or another, whether it's to tighten them or loosen the specs a little bit. So the whole process ensures that we get very good specifications and that the end user, when this equipment is deployed, has a very good experience. So the final thing I just mention as an example, probably all of you know that we have congestion notification and congestion control, and it's a good example of how all these mechanisms work together, because the physical layer group in the Volume 2 spec will define the hardware mechanisms to provide congestion control. But the Volume 1 spec, the people there have to incorporate that into the software side and the protocol side so that we interface well with the hardware, so that we know when there is congestion. We define mechanisms for telling both a requester and a responder to back off if the network gets congested. So that's the relationship between the two specs and why both of them are very important within the IBTA architecture. So, Bill, I'll turn it back over to you, if you like, on the rest of the slides.
Great. Thanks, Rupert. The InfiniBand Trade Association specification is important. The latest that comes out tends to be first adopted in supercomputing space, but we found that the supercomputing space is a precursor to enterprise adoption. On slide 6, you can see that the InfiniBand attachment rate is growing for many years. It is now the highest used interconnect. And again, it's for a reason. Supercomputing cluster designers want to be able to get the highest performing systems for what they're building. On slide 7, you can see that of the highest performing systems, these are the petaflop systems on the top 500, almost half of them are InfiniBand. The others that are on that list are all proprietary. IT managers are looking for a high-performance interconnect to get the most performance out of their systems, but using an open standard multi-vendor product, InfiniBand is the way to go. But it's not just about performance. On slide 8, you see a chart here where you see the efficiency of every system on the top 500. Those blue dots at the top, those are all InfiniBand clusters, proving that InfiniBand gives you the highest performance of these clustered systems. At the other scale, the orange dots on the lower right, those are all gigabit Ethernet systems, showing that in this environment, you get anywhere from 30 to 50% efficiency on every server you add to the cluster. You see on slide 9 representatives from Tier 1 OEMs, vendors, system operators, system suppliers. All of these members are interested in expanding the InfiniBand capabilities. We invite those of you who are interested in joining us to check out our website and potentially becoming a member. Thank you.
Well, great. Thanks for that, Bill. You know, a question comes to mind as you guys go through these specifications. Is InfiniBand, is there a point where copper is not going to be feasible for conducting these signals, or have we already past that point?
Bill, we're losing you a bit, so I think I'll answer the question if I may. So I was just going to say that copper is still an important part of our fabric. And in fact, as you probably know, we've just recently deployed EDR devices running at 100 gigs per second. And we have been already testing and qualified a series of EDR cables, and they will reach up to, currently it's about 3 meters, which is about 10 feet. And if a greater distance is needed, then we have optical solutions, to go between racks and things like that. And the optical obviously can easily go up to 100 meters with optical.
Wow, terrific. And I know you guys have an event coming up with the Open Fabrics guys. And Rupert, I know you're always giving training sessions there. I was wondering if you could give me a preview of what's coming up at the Open Fabrics workshop.
Sure. Yeah, we've got a pretty exciting agenda coming up. One of the new things that's going on there is that we formed a new group called the Open Fabrics Interface Working Group, and we've got a whole new API called libfabrics. And this new API is intended to reach out to all of the application developers who have specific needs and who have really come to us and asked us to provide them with an easier-to-use API, number one, and an API that addresses their particular needs. So, for instance, the OpenMPI group has very specific needs. They need to be able to directly access and manipulate memory, and we're building into this API the functionality to do that. So the Developers Conference is very much for not only us to present to all of the community, but for us to listen to the community and find out what they need and incorporate it into the Open Fabrics enterprise distribution.
And great. And so remind me again, when does that take place? What's the first day? It's a Sunday, right?
Yeah, that's right. Sunday the 15th, that starts, and it goes through to March 18th on Wednesday. And then after that, we also have a users workshop that runs the rest of Wednesday, Thursday, and Friday. And what that focuses on is more of the fabric administration side of things. So we're really looking for system administrators, people that are bringing up, these clusters of 1,000 or 10,000 nodes, who want to learn from other people, like the government labs that have, got clusters in the tens of thousands. And so we focus on the user in that second part of the conference.
Well, before you guys go, I wanted to ask you about one aspect in particular about that conference, and it was about systems on a chip, right? And this seemed very exciting to me, the idea that we could have these small devices with InfiniBand or high-speed interfaces. So what can you tell me about that?
So that's a very hot topic that we've definitely included in our presentation during this event. And as you said, this is a whole new area for the Open Fabric software. We're trying to work closely with the people doing ARM as well as SoC, System on a Chip. And we see a bright future for RDMA with these new technologies coming up.
Oh, that's terrific. Well, Rupert and Bill, I want to thank you once again for coming on the show today.
Well, great. It's very nice of you to have us, and we look forward to seeing you at the Developers Conference.
All right, guys, that's it for the Rich Report. Stay tuned for more news and information on high-performance computing.